Hello, everyone, and welcome back. A little bit of an unusual setup today since we're going to be making use of something called the OMNI calculator to help us in our calculations. And so we're looking at the idea of a future value of an annuity. So what is this? So an annuity is a series of equal payments made at equal time intervals. Each deposit is made at the end of that. And so we're going to be using something called the OMNI calculator to help us. I took a screenshot on the right of what this looks like, and we'll go through the amounts. But what's the purpose of this? Well, I had alluded to before in the lesson of last time that with respect to saving up for the future, it wasn't really realistic for us to say I want to deposit $25,000 at a given and earn money at a given percent or interest rate. What was much more realistic was the idea of instead saving a regular amount of money each month or each week or each year or what have you. And that's what we're going to be looking at today. And so you do need this calculator in order to continue. So I'll put this on any page that you are required to use this. So here I list it up for you, and it'll come out to this stuff on the side. So what do we have here? We have some buttons here. So the payment amount is the amount of the regular payment, meaning how much do we have to pay each month or what have you. The interest rate we just list in as a percent. The annuity term is going to be years. Compounding frequency means how often is it compounded? And it says that in the question. It'll be yearly, biannually, which on here will be semi-annual. So when I go to compound frequency, I have the options of yearly, biannual, quarterly. So just note that semi-annual and biannual are the same thing. Quarterly, monthly, weekly, and the payment frequency is going to be the same as the compounding frequency. Okay, and so here's a screenshot of that. And so now we're going to see what this looks like in practice. And so we have Noah who deposits $1,500 at the end of each year into an account that pays 6% compounded annually. So what does this look like? Well, so here it's the payment amount is 1,500. Okay, so we can still highlight all of the information that we need. It's still 6% compounded annually, and it's still every 15 years. So those are the things that I need. Okay, so the interest is 6%, and it's going to be for 15 years. Okay, and it's compounded annually. Okay, those are the three pieces of information I need in order to continue. All right. And so when I say annually, this just of course means also yearly, right? For our calculator purposes, this is the same thing as annually. So what do I do now? Well, in the payment amount, I'm going to type in 1,500. In the interest rate, I'm going to type in 6%, so just a regular 6. We put the annuity term. This will always be in years, so I'll just put my 15 years there. And I want to make sure that it's compounded yearly. So I want my compounding frequency and my payment frequency to both be yearly. And in fact, this is what the answer is going to be. And so what you can do then is to take your snipping tool and you can copy, and if you wish, you could just take a screenshot of this and just post it off to the side here. And that's what we get as our answer. Now, I just wrote down what's going to be in each one just so that it's that way it's easier for you to review. But for us, it's just enough to kind of write down what you had in each section and just copy it over. And that's kind of ideally what I'd like you to do. So remember, in your search bar at the bottom, you want to type where it says type here to search, type in there, start typing in SNP, and it will show up as an option. And so for these things, that's kind of like the main idea that we're gonna be doing. There is still some calculator work we can do. So for example, how much did Noah earn in interest for his annuity in example 1? And so for the formula for the interest will be equal to the future value minus sign, and these are called future value of an annuity because remember, we're saving this for the future. That's why we call this a future value of an annuity. So it'll be future value minus sign the payment amount multiplied by the number of payments. So what does this look like? So the interest will be this 913.95 minus the payment amount, which we said was this $1,500. And how many times did we pay this? Well, this one ended up being yearly, right? So the number of payments will be equal to the years multiplied by compounding frequency. Okay, so for us, that means it's going to be, well, it's 15 years times once for annually, so it's going to be 15. So we're going to take our 34,913 and minus off 1,500 times 15. And so on our calculator, if we take 34,913.95 minus off 1,500 times 15, we're going to get here this 12,000 number as an answer. So again, we take our 34,913.95 minus 1,500 times 15. And we're going to get that number up here, this 12,000 number. And so the amount of interest that we earned was and is going to be this 12,000. Okay. So what do we do for the next one? Well, again, same kind of idea. Stephen wants to buy a $5,000 car when he graduates from high school. He deposits $85 at the end of each month in an account that pays 9% compounded monthly. Stephen will graduate in 4 years. Will he have enough money by then? And so here, we're going to be using our calculator from before. So the payment amount is going to be equal to this $85. The annuity term is going to be equal to 4 years because he said that this was going to be for 4 years this time. Oh, we should go the other way. Okay. And it's going to be 9% compounded monthly. So the interest rate will be equal to 9%. And the compounding frequency and the payment frequency, so the compounding slash payment frequency will both be monthly. Okay, and so let's see what we're going to do then. So over here, we're going to type in for the payment amount, we're going to put in 85. The interest rate is going to be 9. The number of years that we're talking about is going to be 4. And for our compounding frequency, we're going to change it from yearly to monthly and change the payment frequency over from yearly to monthly. So again, what did we do? Well, the payment amount, we input this as 85. The interest rate we said was 9 because it's 9%. We're talking about 4 years. The compounding frequency, we had to switch over to monthly. And the payment frequency, we had to change over to monthly. Depending on the question, sometimes you end up reusing, like it might be monthly, then monthly again, but just always make sure that this is the case. And so here, what is our solution? Well, we end up with a future value equal to 4,889.26. Okay. And here is our picture to show, hey, this is what we did. So you should always include this as well. Or you can just do what I did. You can just type it out here and then write your answer afterwards. I'll include the image just so that way you can see what it looks like. But we are not done because the question was, will he have enough money by then? So this 5,000 wasn't really used at all except to say that at the end, he needed a certain amount of money. And in fact, he needed 5,000 and he's going to be short. So the answer to this question is no, he will not have enough money enough money saved by the time he graduates. So it's worth noting for this particular example that when you're going ahead to solve this question, make it said pay close attention to the values that you're inputting in and make sure you answer the question completely. And so now, as you're going through this, I left some practice questions for you to follow up. Again, you can practice using the calculator that we had from before. Just note, like when it says compounded annually, make sure you go ahead and change it back accordingly or quarterly or what have you. Give you some questions to try out, and then I also left some answers here at the bottom for you to check just to make sure that these end up working out okay. So go ahead and try out these practice questions now. Make sure to compare them, and we'll see how you did.